Hello everyone, my name is Lars Fiedler. I'm the CTO of Composable Analytics, and today I'm going to be discussing handling variability through composability. So just to give you a brief background of where we came from. So Composable Analytics is a recent spin out of the MIT Lincoln Laboratory. So there I was a software engineer and research scientist for a number of years working on big data projects for the government and serious gaming initiatives. And we've been outside the lab for a few years now, working very, very closely with a lot of commercial entities in a variety of different main domains, such as copper and gold exploration, oil and gas, hedge funds, banks, insurance clients, marketing, data vendors. And really our mission as a company is to give enterprises, give the boots on the ground, the IT pros, data scientists, the software engineers, the power to consume, manage, explore, and harness all of their data. So as a community, we've been talking about the V's of big data for a while: volume, variety, velocity, veracity. But one thing that I think we haven't really addressed in a coherent way is application variability. So what is application variability? Well, it's really all the things that you need or would want to do with your data, but you just don't either have the time or the actual resources to do it. You know, our companies are constantly in motion, right? They're not static entities. They're constantly trying to penetrate new markets, add new products, bring on new clients. There's mergers and acquisitions. And so things are constantly in flux, and they're constantly needing more and more data. More and more data sets are coming in, and there's always a need for new software solutions and capabilities on their enterprises. And the problem, right, is that us as data scientists and engineers, we're always trying to play catch up, right? We're always trying to meet the needs of the business, but we're typically kind of trailing behind. And so there really is kind of a need or requirement for platforms and for environments where we can do rapid analysis very, very quickly and develop software solutions and capabilities and get those deployed robustly on the enterprise as quickly as possible, and really as soon as the need is there. So Composable is actually addressing a lot of these things by developing software solutions with the composability principle. And this is basically a design principle that deals with the interrelationships amongst components within your model. And once you've kind of defined your atomic components, you basically you have a system that allows them to be recombined and connected to one another at a later stage, and typically by more of an end user person. And so there's a lot of advantages with a system like this, right? One is it's pluggable, you can reuse those components, you can swap them out for better or newer ones. Your testability of the whole system just goes through the roof as well, because you have these well-defined contracts on these atomic objects. You can individually test those and start combining them together and test larger portions of the system. The late binding configuration portion of composability is one of the big keys, right? Because this begins to allow more end users to actually change the behavior of the system. And you're really starting to blur the lines between what is code and what is configuration in your system. And with these, you're now in a place where you can accommodate those unanticipated needs, those unanticipated data sets that need to be analyzed much more quickly and efficiently. The other thing that I think is really key when developing a model using composability is that you're actually defining a structure, right? and you're then moving that structure into the execution phase. So normally, how people design things, we'll go up to the whiteboard and draw some boxes and arrows, and it normally stops there, right? And we go to our computers and start just typing in code and creating object-oriented programming, but there's typically a disconnect there. And so by using this principle and using a lot of these end-user capabilities, you can really start to bring that structure, from the design phase all the way to the actual execution. So I'm going to kind of touch on three main features in Composable that have used this principle when we developed them. So the first is data flows. So data flows are great for ETL pipelines, ad hoc analytics, blending lots of data sources together, reports, even web services. The query views are great for exploring your data, slicing and dicing, providing drill downs, exporting large swaths of your data, and forms as well. So forms are a great way to basically go from a data model database all the way up to providing a user interface to support CRUD operations. So let's jump into kind of some of the details with data flows. So again, the first thing with composability is it starts with that model. So kind of the atomic building block in data flows are these modules. These are basically the boxes that you see on this graphic. And these are basically instantiations of module types. Module type basically has inputs and outputs, and they do something in the middle. These inputs and outputs are strongly typed, and they have names, descriptions, obviously the type information. These inputs and outputs also support collections and streams as well. And now a data flow is basically many of these modules connected together, and you're connecting the inputs and outputs on the actual module. And one of kind of the key things with the idea of composability is this nesting and the ability to create this hierarchy. And so data flows can actually execute other data flows by externalizing their inputs and outputs. So we've got a few extension points with modules. So the first is obviously the type system. They can basically be as atomic as integers and strings and booleans to all the way up to charts or tables or streams. To avoid having lots and lots of just conversion modules within your flows, we do loosen the type requirement a bit, where if something's iConvertible or if there's a casting operator there, then we will automatically convert those types for the person. So if you're going from string to integer or integer to string, you can feed those in. You just may get an actual runtime error. And then obviously the actual execution routines within the modules as well is another extension point. On the UI side, we basically have two main extension points. One are the input controls. So this is how you specify kind of the default value, and they can be things like spin controls, drop downs, even choosing a region on a map. And then on the other side, the rendering of the outputs. So that can be charts, maybe it's just a JSON structure as well. The other thing with this as well is that you have to worry about versioning. So on a module, right, you basically have the inputs and outputs, and they're essentially a contract, right, or an interface that you've then published. And you want to try and get that as perfect as you can the first time. But more times than you would not want is that you end up not getting that interface correct, right? You may want to rename one of the inputs or outputs. You may want to change a type, add an input, remove an output. And so the problem is, right, is people are now have created data flows that are actually, depending on those. So what do you do? So Composable basically has an upgrade story for modules where the developer can inject upgrade essentially classes to move the modules from one version to another. And there they can add inputs, remove inputs, and this will actually adjust the connections to those as well. And this is all also within kind of the undo redo stack within the designer as well. So people can optionally upgrade to newer versions of modules as well. So how are we executing all these flows? So it's essentially you're creating a DAG, a direct acyclical graph, and so you could basically just do a topological sort right on there and execute that in that order. But we can obviously do better than that because these modules or because it's a DAG and you're defining your dependencies as opposed to execution order, the system can basically execute modules in parallel with one another. So example in this graph, right, B and F could be executed at the same time as well as C and D. A few different ways you can actually on where the execution is happening. One is you could use more of a central orchestration where all of the nodes are actually, or all the modules are being executed on a single composable node. Or because with our type system, everything is serializable, or at least there are references that are serializable that are then kind of actually just pointing to a larger file on disks. So that's to kind of handle some of the more larger kind of pieces that are not either streaming or small enough to fit in memory. And so basically the idea there is that every node will have access to that, those references as well. And so you can basically distribute the module execution across these nodes. We also support looping, so you can basically execute modules downstream from you multiple times. Also branching is supported as well, so that certain portions of the graph can be executed or not executed. So let me jump into a demo, show you how some of this stuff works. So I'm going to log into our cloud instance. So this is kind of our almost like our iGoogle in Composable, where you can get access to your favorite apps, boards, groups. You can see what new applications people have created. Here we kind of have our Discover page. So this is where you're going to find apps, users, groups. So we'll go ahead and just pop one of these open in our designer to show you some stuff. So here on the left hand side we basically have a palette of modules. Here's one module. You see that it has inputs on the left and outputs on the right. Here we're just running a simple query against a database, and we can get back to some tabular data. Now, let's say we wanted to do a group by on a database. So here we're looking at ER visits by age group. And let's say we want to plot that data. So I can then feed it into a chart. Have age on the x-axis and visits on the y. You can then very easily get out a chart. And let's say we wanted to send that out to some people. So one thing to note that the system's actually recommending what modules I should probably want to connect with this, but you can always go over here, right, and just grab a module and then connect it yourself. Let's save that. Now we're basically going from data in database to visualization to basically mail very, very quickly. And now let's say you wanted to have this thing be running behind the scene, every day at 9:01. Now, the other thing to note, right, again, is all of these types are strongly typed. So here we have a nullable int32. Here's a string. This one's a table. This one's a series object, and this one's a date time. So, instead of looking at all the data, right, we can actually start to do things like, the visit date is greater than some threshold. So we can take our date, and I'll use the date time calculator, and subtract off 1 day from our current time, and then I'll use the formatter here, and I'll pipe that date as a parameter here, and there's our query, and then we'll feed our query into here. And now, right, we've got a complete end-to-end application that's going to be running every day at 9 a.m., running this sliding query, producing a chart, converting it to a JPEG, attaching that to an email, and sending it out. You can put this into debug mode. You can start to step through the execution, see what it's doing. You can look at the intermediate results here. Okay. Query views. So query views, again, are built on the composability principle. The atomic object is the actual query view, and that contains the actual query, so the string, which is actually a templated query, and I'll show you that in the demo. The query view also has inputs, so these are various knobs, like filters, and other parameters that you want to specify. And again, going back to kind of that hierarchy or recursive nature, is that you can actually have query views be nested. So query view can have children, and this allows for drill downs. There's also a bit of interplay between query views and data flows as well. So data flows can execute query views and get that out. Query views can also execute data flows if you want people to, you can basically add buttons to query views and have people do stuff on based on the data that they're seeing. So show you this one. So here we're looking at some syndromic data, but you can also drill down. So here we're looking at, for a given visit, you can actually look at similar visits to that same site based on that chief complaint. So basically, these these columns of data are basically being used as parameters into a nested query, and you can be, you can choose different filters here, and this is all auto-generated as well. So if you want to see how this is being done, basically all you do is just stick in a templated query here. So if you want it to be orderable, if you want paging, you can do that. Here are all the filter parameters here, and you can then specify all your inputs right here as well. So this one's actually looking at a lot of cyber-related data. So these are all network flow events. This data set is I think a couple 100 million rows, and scales very, very nicely. You can page through the results very, very quickly, and this is basically looking at a rolled up the number of bytes by destination computer. And then finally, the last feature I want to go over is forms within Composable, and this really simplifies basically creating a data model, creating a database, and the whole web UI to support CRUD operations on that. So again, it goes back to your model and creating that atomic object. In this case, it's the container, which has fields. Fields are basically have names, descriptions, types, what type of control you want to display on the UI. And again, going back, there is a hierarchy here, so containers can be chained together, so you can support one-to-many relationships or one-to-one relationships with containers. And that'll get you, typically 60 or 70% of the actual data models that exist out there. But to support kind of those more many-to-many relationships, we have this concept of junction containers, which allow you to go across the hierarchy. Let me show you that. So here we have a form. Again, you can very, very easily go through the whole hierarchy of your data model right here. This particular form, I think it's about 500 tables are backing it. This is all completely auto-generated, no code necessary to create any of this. So you can save it, you can export data. You can look at history, so we record all the history of any changes that happen to any of the container instances. So with that, I'd like to just kind of wrap up. And so hopefully this has kind of inspired you guys a little bit to think about using composability in your next software project. So just a few tips on composability and what's the best way to tackle this. So when you're coming up with your objects and your model, they should be atomic yet high level at the same time. And that may sound like a little bit of an oxymoron, but what I mean by that is that they're high level in the sense that they're probably not one-to-one with a line of code, but they should be atomic within your data model, right? So, modules are atomic, within that higher level data model. If you were to probably, if you were to go out and create maybe the next generation of interactive dashboards, right, you might have some sort of board item or something like that, and you could chain or nest boards together. So you want to provide enough flexibility, but the composite object should be easy to create. It is hard to think about in deconstructing a problem at first, but once you do that, there's it really gives a lot of power to the end user, and I think it actually a lot of times the simpler models are a lot of times the more powerful ones as well. So how do you know you've succeeded? Well, one is it should be creating one of these new composites should be very easy to the user, right? It should be very quick. You should be able to support a large number of different composites there, right? If you can only really support one or two, or the family of composites is not very large, then you probably your atomic objects are probably not atomic enough, and they're probably too big and bulky where you can't actually do a lot of things with them. Going back to the recursive nature, so that's really key to support a recursive nature within your model. And I think finally, the biggest litmus test is, with your model in your composable system, is if users start to create composites that you never thought or felt were even possible when you're first designing this. I think that's a good test to know that you've hit the sweet spot.